Okay, and we're off. So, from yesterday, we worked on our class activity where we had the different dishes. We had 9 different dishes, and you had to put them into groups, and then you had to look up in the book words from the first section of chapter 2 on which words you thought best went with your groups, with your dishes, etc. By the way, for those watching on the video, I will go through the example sheet, and I will take my camera and go over each of the dishes so that you can see it at the end. So for those of you watching on the camera, you'll get to see that at the end. So follow through with this, and obviously from there we'll go on from there. Okay. So from what you guys got there from your particular groups, and now granted, obviously with a certain amount of people that are gone today, I know that obviously you're not in your groups or whichever, but what I'm going to have you guys do is each one of you, at some point, I'll just call on you and ask, okay, like, say dish 1, for example. I'll say, Kaylee, dish 1, what is one of the words that you use to describe dish 1 or the group that dish 1 belonged to? So, actually, since I picked on you to start with, group 1, what in particular did you and your partners have to say about dish 1 in terms of like describing it?
We had 1, 3, and 9 like in a group.
1, 3, and 9 in a group, okay. So 1, 3, and 9. Did you find any particular vocab word that you felt strongly described dishes 1, 3, and 9?
Heterogeneous mixture.
Heterogeneous mixture, okay. Okay, so heterogeneous mixture. So what did you guys see about what a heterogeneous mixture is?
Because you could see the difference with the nuts and the bolts.
Yeah, you can see the different parts, the nuts and the bolts. So like in number 9 here, we've got a long bolt, we've got a short bolt, we have what I call hex nuts. In other words, hex meaning that it's got 6 sides to it. We've got washers, and we've got, I think these are square washers, I do believe, aren't they? Square washers? Yeah, we'll call them square washers. So, thank you. Okay? So, you haven't missed too much yet, Annabelle. What we're doing is we're just going over from the lab the dishes that you guys found. Okay? So you're just getting right in at the right time. Okay, so 1, 3, and 9 we're calling a heterogeneous mixture. You can see the different parts, okay? Sam, what's one that you had? It was what, you and Michaela, I assume?
And
Randy? Okay. So what's one that the 3 of you guys had?
We had dishes 2, 5, and 9.
Okay.
They all had unconnected parts.
Unconnected parts, so, okay, very true. 2, 5, and 9. And, there's number 9. So we've got 9 down as a heterogeneous mixture where it has all sorts of different parts in it. I want to challenge you on this one. How are number 2 and number 5 similar to one another?
They're in a clear container.
That's true, they are in a clear container, okay. But is there anything unique about number 2 and number 5 that sets them apart from number 9?
One has just nuts and one has just bolts.
Yeah. One has just nuts, one has just bolts. So the just bolts, the just nuts. Whereas number 9 contain the mix. Okay? So number 9 contained just a mix. Did you guys have a term, did anyone have a term, or did you guys happen to see a term that makes you think, aha, that'd be a good one to describe 2 and 5? Does anything come to mind from what you've seen of the words in the book?
After very long minute researching, we couldn't find one that worked very well, so we just said
Said
atoms.
Atoms?
They're made of
They're made of
Pure
atoms.
substance.
Okay, they are true. A pure substance. Why a pure substance?
Because they're just one thing.
Very true. Okay, so pure substance.
Well, could they be alloys then?
Could they be what?
Alloys?
How so?
Well, pure substance is just one, like, substance, correct? But an alloy is like those metals to strengthen other metal, like steel is an alloy, isn't it?
True, it is. I admit I'm not looking that far, but, and that's something we can describe actually in a little bit too. Remind me as we get later on in this section, because alloy actually does fit the category of one of those vocab words that we do have in here. Okay, now, besides just a pure substance, is there anything else in there that can also fit 2 and 5?
Element.
An element. What's an element?
A part of something.
Dig a little deeper, see what you can find.
Special particle? Specific one?
It's a substance that cannot be broken down into simpler substances.
Okay, is that defining element or pure substance?
Element.
Okay, so it can't be broken down into anything else. Okay? What was it? I'm sorry, one more time. What did the book say on it?
An element is a substance that cannot be broken down into simpler
Okay,
substances.
substance that cannot be broken down any further. Now I want to go a little more into that one. Okay, you heard me talking about it earlier, especially with my little joke. Element. Where have you heard of that before? Very good. The periodic table of elements. Okay? The periodic table of elements. Guess what? All of those elements have mass. From last unit, what did we figure out about what is mass? What is mass? Matter. Huh?
Basic unit of matter.
Basic unit of matter. What is everything, what is all the basic, what is the basic unit of matter? What's everything made up of? An atom. That's why you should never trust them. They make up everything. Never, never trust an atom. They make up everything. Okay, so yes, an element is a substance that can't be broken down any further because it's an atom. It's an atom of a pure element. Okay? So elements, substance that can't be broken down any further, they are one type of atom. And our periodic table of elements is our resource for how many elements that we have discovered on this earth. And also in a laboratory setting. In fact, what scientists have done is they've been able to use particle accelerators to recreate. In fact, that's actually something they've done at CERN. If you've ever heard about CERN before, for those of you that haven't, CERN is like this big scientific laboratory in Europe, I believe in Switzerland actually, where they have like the top scientists of the world doing experiments. They have a particle collider where they've been basically able to recreate mini Big Bangs, and from that they've been able to detect certain kinds of elements being formed. And so on the periodic table, like if you've ever looked at this one before, you'll see some that are grayish in color. Those are the ones that have been created in a laboratory, or I guess you could say are synthetic elements, especially the ones that have kind of some weird long names like 110 unanilium. So that would be an example of one. But nonetheless, so the periodic table of elements, those are all the different kinds of atoms that exist on this earth or that existed at one point in time from either when the earth was created or from the Big Bang. Okay? That's what an element is. And we have that perfect example here with number 2, because these are just bolts. That's all they are. 5 is just nuts. They're all the same kind of nut. Okay. So we've got 1, 2, 3, 4, 6, 7, and 8. We still have yet to classify. Let's see. Got Kaylee already, Sam, Michaela, Randy. Michael, who were you with? There's 2 of you guys? Okay. What's one group that you guys have?
3 and 6.
3 and 6, okay. So we've got 3 up there already as a heterogeneous mixture. Let's take a look at number 6. There we go. All right, so 3 itself was just 2, what I'd call either square nuts or square washers, a short little bolt, and a washer, okay? Number 6 was these 2 things. What's different about number 6 and number 3?
One's got a lot, one's got one.
Yeah, one's got different types of substances, one's just got one type of substance. So, to start with, what could we call tray number 6 then? Since it's just one type of substance.
Pure
We call it pure substance, yeah. So we can add 6 to the list of pure substances. Now,
But isn't 6 like a couple different pure substances?
it is. Okay, so obviously, is this just one type of thing? In terms of, is there, if we're talking atoms, is there more than one type of atom in this? Yes, okay. So do we,
It's not pure. What?
but notice how it's put together.
Yeah.
They're put together the same way. Is there anything in there that you found that describes something that has more than one part and they're put together in the same way or ratio? Compound, yes. So we can also describe, so 2 and 5 were elements. They are a pure substance and an element. And so far we've got a compound, which would then classify number 6. Okay? So what's it say specifically about a compound?
Compound is a substance that is made of 2 or more simpler substances and can be broken down into those simpler substances.
Okay, so made of 2 or more what? Just
Substances.
substances. And what did it say about broken down?
And it can be broken back down into them.
Okay.
2 or more different substances.
Okay, so made of 2 or more substances and can be broken down further. Does it say anything about ratios in there in reference to a compound? Does it say anything about ratios? You'll notice like with a compound say, if we're calling this a compound's always going to contain the same ratio of parts. Okay, so we'll want to add that to it. So it always contains same ratio of parts. Okay, so if it's a specific compound, it's always going to contain that same ratio of parts. Otherwise, it's a different compound. Now, how is a compound different from a mixture, though? How is a compound different from a mixture?
In the definition of a mixture, it didn't say it was a pure substance that was in it.
Okay. So, all right, I'll give you a little example here. With a mixture, I would not be able to do this. Take it off.
With mixtures, with compounds, you can break them down.
Right. And what I'm trying to show you here is that a compound, everything is put together, I guess you could say. You know, you have things that are like stuck together. Whereas in a mixture, you can have random amounts of A, random amounts of B, random amounts of C, and they're just all there. They're not combined. Whereas in a compound, these different things that are there combine with one another. So it's made of two or more substances combined with one another. Shall I get rid of that? So made of two more substances combined with one another, and it can be broken down further. Always contains the same ratio of parts. Whereas a mixture, nothing is combined. There's nothing combined in a mixture. Okay, so we've got 1, 2, 3, don't have 4 yet, 5, 6, don't have 7 or 8. So let's see, I'm missing 4, 7, and 8. Okay, 4.
I had 4 in a pure substance.
Okay. Ah, there it is. So 4, a pure substance, and
That's just what Blaze told me there.
yeah. That he would be? Well, from what you're seeing of a pure substance, what do you think? Is here. Are there any kind of somewhat similarities between the two?
Yeah.
How? What similarities?
They're the same color.
True.
Both have nuts and washers on the boat.
They both have what?
Nuts and washers on
Yeah, they both have nuts and washers on them. Exactly. Yeah. So you could say that they're both what if they're a pure substance? Element or compound?
Element?
Compound. Yep.
Oh.
Remember, because an element is just one thing. Compound is more than one thing. Two or more things put together in a ratio. Okay. So we could say that number 4 is a compound, and it's also a pure substance. All right, so 1, 2, 3, 4, 5, 6, 7, and 8. We need to get there. Okay. Actually, 7 is kind of a weird one. It's two things in one, I guess you could say. So these are the two things that were found in dish number 7. So are they put together or are they separate? Do I have mixture? Do I have a mixture? Do I have a compound? Do I have pure substance? Do I have element? I do have a mixture, okay? So 7 would classify as a mixture. Okay. Now, each individual piece of it, okay? So it is a mixture because I have two different things, but these individual pieces, what could we classify these as from what we were seeing earlier? Or just a moment ago for that matter too.
I'm guessing pure substance.
Well, I guess what I was trying to compare was, here, I'll tell you what, here's one from number 6.
Compound?
Compound, yeah. So 7 is a mixture of compounds. So in other words, I'm showing you in this one 2 different compounds.
Wait, what's a mixture of compounds?
7, because I have 2 different compounds.
So didn't you say a mixture can't be broken down? Those two are both separate, so can't
You just told me.
But,
It's a mixture of anyway, not that that's important too much. I guess the main idea being that I have two different substances in here. Go ahead, Kaylee, go ahead.
She doesn't know.
Okay, no, and that's, if the question, if it pops up, just ask, that's fine.
I'm just confused, because how can a pure substance be a compound? Because a pure substance is made of one thing, that's made of two or more.
Okay,
You can't say-
okay, I see where you're going. How about this? We'll take it away from the pure substances category. We'll just go with the fact that they're mixtures.
That's,
You broke it.
okay.
Okay, if that makes a little better sense. In other words, I'm just trying to show you that in here, that this would be a mixture because you have two things that are different.
But,
What's the exact definition of mixture that you're trying to tell us?
Okay, well, let's see what we got in here for mixture then.
I'm more confused with 6 and 4. How can they be a pure substance made of one thing, but then they have two or more substances?
Here's the thing about it. What makes it a pure substance is the fact that you have two or more things combined together.
But pure substance is made of one thing.
They took two pure substances and then just mashed them together.
So is
Okay.
it not?
Okay, here's a classic example of a compound that's a pure substance. And this is one you all should know. What's the formula of water? There you go,
But that would be,
H2O.
but it's made of two or more things.
Yeah, it is.
So it's not a pure substance because pure substances are made of one thing.
Yeah.
You guys are making this too complicated. Just
Let's
do
take
it.
a look at pure,
It's
take a look at
just
pure,
going off the
okay,
definition. Pure substance
Take-
has to have one thing, compound says it has
Okay.
two, they can't be both.
yeah,
It's not right.
Kleenex.
Science is rules, not exceptions.
In everything, there always tends to be an exception to the rule. Okay, a pure substance, according to what our definition has here, matter that has exactly the same composition. Matter that has exactly the same composition. So maybe we need to modify our definition then. And it says every sample of a given substance has the same properties because a substance has a fixed, uniform composition. Okay, I see the confused look for you. Go, please, go ahead. Whatever questions, anything that you got.
Just keep on teaching.
Oh, no, okay, so let's modify this according to what we got in there. Because I think the one thing is throwing us off, okay? So, it says here, pure substance, it's the same composition. So same composition. Same properties. And fixed ratios. Which is perfect for an element because it's only one. But for a compound, it's two or more. So like with water, H2O, hydrogen is an element, which is a pure substance. Oxygen is an element, which is a pure substance. You put them together, you now have two or more pure substances. And we all know that this water, obviously, water is a compound.
You just said it was pure substance?
Yeah.
It is, it's both.
How?
Okay, okay,
I think
let's
we
make a
should
little
just
flow
do
chart
that.
here.
I think we should just go to 8 now.
Yeah.
So we made them last
Let's
time.
skip this unit and go to the next.
Yeah, that's an idea.
Or we
it's not that bad, it's really not.
I thought this wasn't supposed to take very long.
Yeah,
It-
I thought that was.
Well, you know how that goes sometimes, I guess.
And that camera's still going. I did all this.
Okay, so an element and a compound are both classified as pure substances because a pure substance, according to that, has the same composition and the same properties and fixed ratios. So with an element, obviously, its ratio is it only has one type of thing.
So what is it? So is everything a pure substance?
Yeah.
Mixtures would not be. Okay, let's take a look at mixtures then. What does it say about mixtures?
It says in bold print that the properties of a mixture can vary because the composition of a mixture is not fixed.
Yes. Yep. So the properties of a mixture vary because the composition of a mixture is not fixed. So in other words, a compound is unique because it has its own properties. The properties of a compound are different from that of an element. A compound, hydrogen gas and oxygen gas. Oxygen is actually very flammable as a gas. Hydrogen, not so much. But both of them are gases. You put it together and you form water, and water has its own unique properties to it as a chemical. It supports all of life, it supports us. Whereas in a mixture, they show an example here in the textbook there of sand. You can see the different particles that make up the sand. Or you could make a mixture of oil and water. Ever tried that before? No. Can you see the oil and the water? Yeah. Exactly. Okay, here's another one. You were just asking about it a little bit ago. Alloy. What is an alloy?
Two different metals used together to make that product stronger.
Right. Do you know what one of the metals is that they use to help make metal stronger?
I don't know
Oh.
that.
They tend to use, okay, so steel is a combination of iron and I believe like aluminum and titanium. What do you know about aluminum in general? What's an element? Okay. Iron and aluminum, in terms of heaviness, which is generally the more heavier metal? Iron. Why do you suppose they try to blend in aluminum in a lot of metals? To give it more lightweight. It's still a pretty strong, sturdy metal, but yet is lightweight. Obviously, I know we have aluminum cans. Those are really thin pieces of aluminum. But if you get, heavier, thicker pieces of aluminum, it's pretty strong. So they use aluminum to blend in with other metals. Well, depending on the type of metal that you blend in, all that is, it's a big mixture. And you can make the metal either stronger or heavier or etc. It just depends on which one of the metals that you blend in with it. So in other words, it's almost kind of like making a milkshake. Where you're taking and you're blending in, you could be blending in fruit. You could be blending in ice cream, and you're blending in milk. And you're blending in some type of, maybe a malt deal with it, and chocolate syrup. I know, sorry to make you hungry after lunch for dessert. Anyway, you get the idea. If you want to make the milkshake chocolatier, what do you gotta add?
Chocolate?
More chocolate sauce. So now the milkshake is taking on more of the flavor of the chocolate sauce. Well, what if you want it more fruity?
And fruit.
Add more fruit. And you make the composition more fruity. So it's a mixture in which however much of one thing that you add to it, it's gonna take on more of the composition of that one thing because those mixtures are not combined, whereas in a compound they are. So in a mixture, you can see the different parts. There is no specific ratio. And they are not combined. I should say the substances are not combined. And that's why there's no specific ratio, because you're not actually combining substances in a specific ratio. Water is made the same way every time. 2 hydrogens, 1 oxygen. Guess what? If you throw in a second oxygen to the forming of water, now what do you have? Peroxide. And peroxide's a completely different chemical than water. That's the joke that I've often told before about one guy walks into a bar, says, I'll have some H2O, and then the other guy says, oh, that sounds good. I'll have some H2O too. He died the next day. What happened? He drank peroxide. You can't live and drink peroxide. You can only live and drink water.
Yeah, you can. Sometimes when dogs eat bad things, you feed them peroxide and they just throw the bad thing up and they go on living.
That's true. Okay, whatever. You get my drift though. Water's not, we can't live off of peroxide. We live off of water. We've got to have clean water in order to survive, okay? I'm going to stop things right there for now. No assignment tonight, so you don't have to worry about that anyway. But we'll continue on with this tomorrow. So again, for now we've got, with the heterogeneous mixture, you can see the different parts. There is no specific